Salam, peace be upon you. My name is Muhammad Laïq Siddiqui, the father of Holophase. Remember the language we're learning. There is one field, phi, the holophase, a cyclic rhythm defined at every point in the universe. Its first derivatives give three simultaneous echoes: time, omega, space, k, and motion, v, built from both. Above them, higher derivatives form a branching tree that, in principle, goes on forever. Every law of nature is a pattern in this tree of derivatives of phi. Today, we take a single breath and capture the complete essence of episode 9 as one simple, powerful story, so you can hold the whole episode in your mind at once. Episode 8 is conceptually complete. It built the language in the Platonic realm. What phi is, why only differences matter, how the alphabet grows into an infinite tree, how topology creates discrete knots, how waves carry messages, how identities persist, how equivalence works, and why we need the canonical holophase language standard so the language can be shared without dialects. Episode 9 is the moment we step out of the clean classroom and into the noisy world. Episode 9 is not more poetry. It is the bridge between a perfect language and imperfect measurements. It is the art of reading reality with limited eyes, limited instruments, and limited patience, and still being honest. To understand episode 9, imagine you're handed a magnificent book written in an unknown script. You are told, this book contains every story that could ever exist. That is episode 8, the library of possible sentences in phi. But then you are told something harder. You are not allowed to read the pages directly. You may only listen to the sound of pages turning through a wall. You may only catch a few words through a cracked door. You may only see faint ink impressions through the cover. That is episode 9. Episode 9 is learning to read the book without ever touching the pages. This is why episode 9 has one central mission: operational literacy. Not just I can imagine what omega and k mean, but I can measure signatures in time, in space, and in motion, and infer the corresponding phi derivative structure with known uncertainty. Episode 9 makes the language scientific in the most practical sense. It teaches you how to extract letters from data, how to test grammar against measurements, and how to decide whether two different-looking descriptions are actually the same sentence of reality. Now let me tell the whole essence of episode 9 as one everyday story. Imagine a vast city at night. You are standing on a hill and you cannot walk into the city. You can only watch it from far away. You see lights blinking, you see traffic lines moving, you see districts brightening and dimming, you see occasional blackouts, and you see patterns that repeat every evening. You are asked, describe the life of this city in one coherent language. If you try to list every citizen and every car, you will fail. But if you find the right language, you can describe the city using rhythms, structures, and flows. In holophase terms, the city is reality, and phi is the hidden rhythm behind it. You cannot see phi directly, just as you cannot see the intentions of every citizen. But you can infer patterns. The blinking lights correspond to temporal signatures, omega and its higher echoes. The spacing of street grids corresponds to spatial signatures, k and its tower. The moving streams of cars correspond to motion signatures, v and its refinements. And the stable landmarks, bridges, roundabouts, power stations, correspond to identities that persist even when the surface details change. Episode 9 teaches you how to do this inference honestly. It teaches you how to say, here's what I know, here's what I estimate, and here's what I cannot yet justify. It is the difference between a confident map and a confident illusion. The first pillar of episode 9 is the idea of a window. A window is not just a time interval on a clock. A window is a licensed region of observation where your instruments can see clearly enough to trust what they report. Think of looking through foggy glass. If the glass is too foggy, you may still see shapes, but you should not claim details. If the glass is clear, you can trust your reading. Episode 9 says, before you claim you have reconstructed the holophase sentence, you must certify your window. You must say, in this region, my coherence is high enough, my signal is stable enough, and my noise is controlled enough to justify reading. This sounds technical, but it is deeply human. It is the difference between hearing a conversation clearly and hearing only muffled sound. If you are outside the room and you hear faint voices, you might guess words, but you should not swear under oath. Episode 9 makes Holophase a court-worthy language. It builds rules for when we are allowed to say, I heard this, and when we must say, I cannot honestly claim that. The second pillar of Episode 9 is reconstruction. Reconstruction is the act of going from observable traces to the underlying fee structure. If you have ever heard a song on a low-quality radio, you know reconstruction. You do not hear every note perfectly. You fill in missing parts by recognizing the pattern. But whole-phase reconstruction is not guesswork. It is constrained by grammar. The derivatives must fit together consistently. The time slice and the space slice must agree as parts of one d-phi. The motion inferred from omega and k must match the motion you observe within error. Episode 9 teaches reconstruction as a disciplined pipeline. Data to letters, letters to grammar checks to predicted behaviors back to data. It is a loop. And the loop matters because the language is not proven by one pretty fit. It is proven by consistency across different windows, different instruments, and different projections. The third pillar of Episode 9 is triunity under measurement. In the Platonic realm, triunity is elegant. One phi, 3 simultaneous echoes. In the real world, triunity becomes a demanding constraint. If your temporal measurement suggests 1 omega and your spatial measurement suggests 1 k, then the motion you observe must match the v implied by them within uncertainty. If not, something is wrong. Your window may be unlicensed, your calibration may be off, your inference method may be biased, or the holophase hypothesis may not apply in that regime. Here is an everyday analogy. Imagine 3 friends describing the same person. One describes their voice, one describes their face, and one describes their walking style. If they are describing the same person, these descriptions must cohere. If one friend says, he has a deep voice, another says, he is a small child, and the third says, he walks like an elderly man, then something is inconsistent. Either they are describing different people, or the room is too dark, or someone is mistaken. Episode 9 makes triunity into a test of whether your descriptions really belong to one underlying entity. The fourth pillar of Episode 9 is uncertainty, and why honest science lives inside error bars. In everyday life, we pretend we see things exactly. In real measurement, every reading has fuzz. If you measure the length of a table with a ruler, you still have a margin, maybe plus or minus 1 millimeter. If you measure a frequency in a noisy recording, you still have a margin. Maybe the peak is broad, maybe the signal drifts. Episode 9 brings this humility into Holophase. It says, your omega is not a perfect number. It is an estimate with an uncertainty. Your k is not a perfect vector. It is an estimate with an uncertainty. And your reconstructed sentence must carry those uncertainties like a passport stamp. Without it, it is not allowed to cross into the world of claims. To make this intuitive, think of photography. If you take a picture in bright daylight, the edges are sharp. If you take a picture in a dark room, the edges blur and the image becomes grainy. You can still recognize a face, but you cannot read tiny text. Episode 9 says, every reconstruction has a sharpness limit. There is a best precision you can hope for given the noise and the window. You do not get to claim more detail than your light allows. The fifth pillar of Episode 9 is independent verification. 2 ways of seeing the same thing. If you only have one witness, you can be fooled. If you have 2 independent witnesses, agreement becomes powerful evidence. Episode 9, therefore, loves dual pipelines. In everyday terms, 2 cameras, 2 microphones, 2 methods of inference. If both pipelines reconstruct the same omega, k, and derived v in the same window, your confidence rises. If they disagree, you do not panic, you diagnose. You ask, did one pipeline assume a wrong model? Did one instrument drift? Did the window coherence drop? Did a hidden bias sneak in? This is also how we build trust between researchers. If 2 laboratories use different instruments and still recover the same canonical holophase sentence, that is not personal belief. That is communal evidence. The sixth pillar of Episode 9 is operational equivalence. When different means the same, but only if reality agrees. Episode 8 taught you representation freedom. Different coordinate choices, different notations, Different gate shifts can write the same meaning. Episode 9 says, in the real world, same meaning must be defined by indistinguishable outcomes under all relevant tests. Two sentences are operationally equivalent if every experiment you can perform in your licensed windows gives the same results within uncertainty. If one description predicts a different interference drift, or a different group speed, or a different defect motion, then they are not the same meaning in the operational sense, even if they look similar on paper. Think of recipes. Two recipes may look different on paper. One says, stir vigorously. Another says, whisk until smooth. One lists temperatures in Celsius, one lists them in Fahrenheit. If both produce the same cake every time, they are operationally equivalent. But if one yields a dry cake and the other yields a moist cake, then they are not the same recipe, even if they share ingredients. Episode 9 makes equivalence into a kitchen test. Not do the words match, but do the outcomes match. The seventh pillar of Episode 9 is canonical standardization. The Holophase language standard becomes a practical necessity. If you want a language to become humanity's language, it must have a standard form. The same is true in engineering drawings, musical notation, and programming languages. Two engineers must compare diagrams and know they are talking about the same machine. Episode 9 says, HLS is not just a document. It is the bridge between one reconstruction and another. It prevents the project from splitting into private dialects. It lets you take a messy, context-dependent description and reduce it to a canonical sentence that any reader can compare. In Episode 9, standardization becomes a workflow. First, you reconstruct a candidate sentence from measurements. Then, you reduce it to canonical form. Same ordering, same conventions, same minimal representation, same declared symmetries. Then you compare it to other reconstructions, from other windows, other labs, other instruments. If the canonical forms match, you have deep evidence you're seeing the same phenomenon. If they do not, you have a precise place to ask, is it a different phenomenon or an avoidable mismatch of representation? The eighth pillar of Episode 9 is falsifiability, spoken in plain language. A real scientific language must be breakable. It must say, here is what would prove me wrong. Episode 9 therefore introduces falsification gates, simple checkpoints that prevent self-deception. For example, if your window coherence is too low, you do not claim a high-order derivative. If two pipelines disagree beyond uncertainty, you do not declare a discovery, you declare an inconsistency. If triunity fails repeatedly in well-controlled settings, you do not explain it away forever. You treat it as evidence against the mapping, and you revise or abandon it. This is not pessimism. It is the dignity of science. It is how a language becomes trustworthy. The ninth pillar of Episode 9 is calibration, the quiet craft of making sure your instruments speak the same language as the world. Calibration sounds boring, but it is where many beautiful theories die. Imagine a clock that runs slightly fast. If you never calibrate it, you will think a train arrived early, a friend lied, or the sun changed its habits. Nothing is wrong with the universe. Your clock is wrong. Episode 9 treats every sensor like a clock. A camera has lens distortion. A microphone has a frequency bias. A detector drifts with temperature. A tracking algorithm can hallucinate patterns that are not really there. Calibrate first. Here is an everyday picture. You are learning a new spoken language, but your headphones exaggerate S sounds and hide T sounds. If you do not know this, you mislearn words. You hear sand, where the real word is stand. Episode 9 insists, fix the headphones or measure the distortion and correct for it. Only then translate what you hear into letters you trust. Calibration also protects triunity. If omega comes from one device, k from another, and v from a tracking method, the three must still reconcile. Calibration removes false disagreements so that any remaining disagreement is meaningful. A real failure of mapping in that regime, or a genuinely new structure that demands a new term in the sentence. The 10th pillar of Episode 9 is the reproducibility pathway, the promise that this language can be practiced by strangers who do not know each other and still converge on the same sentence. In everyday life, a recipe becomes a world recipe only when anyone can cook it and get the same taste. Episode 9 treats every holophase claim the same way. You report your window and its clarity. You report the reconstruction method that turns raw data into omega, k, and derived v. You report the uncertainty range where the sentence still holds. You reduce to canonical form so others can compare results directly. Then anyone can try again. If other readers reproduce the same canonical sentence, the language gains weight. If they cannot reproduce it, the language learns. Sometimes the failure reveals a hidden assumption. Sometimes it reveals a bad window. Sometimes it reveals real variability. And sometimes it reveals a contradiction. Episode 9 teaches you to welcome these outcomes, because they are how a scientific language sharpens itself. This is why Episode 9 is also about humility in community. The goal is not to be the only speaker of Holophase. The goal is a shared tongue, where independent readers can read the same patch of reality and agree, not because they trust each other, but because the method forces agreement when it is deserved. Episode 9 also introduces a simple habit. Keep a measurement diary. Write the settings, the environment, the calibration references, and the exact choices you made. A future you, or another lab, can replay your steps. Without this diary, a result is a rumor. Only repeatability turns a claim into evidence. Now let me show Episode 9 in action through a set of vivid examples. These examples are not random. Each one carries a piece of the whole episode. Example 1. The guitar string. You pluck a guitar string. You cannot see the microscopic motion of every molecule, but you can hear the sound. The sound contains omega, the frequency of vibration. If you record the sound, you can measure omega with a spectrum. You can also see K indirectly by observing the standing wave pattern on the string, maybe with slow motion video or with a dust pattern that gathers at nodes. The spatial pattern has a wavelength, and that corresponds to K. Now motion V is subtle here, because standing waves are a balance of two traveling waves. But you can still track how energy and phase relationships move along the string when you change tension or touch the string lightly. Notice what happened. You did not need metaphysics. You needed a window of clean sound, a window of clear visibility, and a grammar check. That is Episode 9. Example 2. A flashlight through fog. You shine a flashlight through fog. You see a beam that spreads and fades. The spatial profile is changing. Curvature and divergence are active. You can image the beam at different distances. That gives you spatial echoes. You can modulate the light, flickering it in a pattern. That gives you temporal echoes. You can measure the delay of the modulation envelope at different points. That gives you group motion. Episode 9 asks, can we reconstruct a consistent omega k grammar for this medium? And does it predict the spreading you observe? If it does, the sentence is coherent. If not, you refine the sentence or declare the mapping broken. Example 3. A whirlpool in a sink. You pull the plug and the whirlpool forms. Even if you cannot measure every detail of the water, there is something you can count: the winding. You can walk a loop around the vortex and count how many turns the flow phase makes. That integer is robust. It does not drift continuously. It changes only through events like vortex splitting or annihilation. Episode 9 says, topology provides anchors in noisy data, because integers are harder to fake than continuous estimates. If your reconstruction claims the winding number slides smoothly from +1 to +0.6, that is a warning sign. Either your window is bad, or your inference is wrong, or you are measuring something else. Example 4. Two different descriptions, one outcome. Suppose you describe a traveling pulse in two different forms. One is a compact wave packet in real space. The other is a sum of many sinusoidal components in spectral space. They look different, but if they produce the same measured spectrum, the same spatial profile, and the same propagation behavior in every licensed window, then they are operationally equivalent. Episode 9 teaches a deep humility. Do not worship a form. Worship the invariance, what survives coordinate changes, gate shifts, and representation choices. Example 5. Mapping a coastline. If you draw a coastline on a map, the detail depends on scale. From far away, the coast looks smooth. From close up, it has bays, rocks, and fractal jaggedness. Episode 9 says derivatives are like zoom levels. First derivatives give the broad trend. Second derivatives capture curvature. Higher derivatives capture finer roughness. But you cannot claim infinite detail from a blurry satellite image. You must match your derivative order to your resolution. And you must show that adding more detail actually improves predictions beyond uncertainty. Otherwise, you're just painting noise. Example 6. A conversation in a crowded cafe. You are trying to hear your friend speak in a noisy cafe. At first, you catch only rhythm and loudness. That is like measuring low-order temporal features. If you move closer, you catch syllables and words. That is like accessing higher-order structure. If you record the sound with two microphones in two positions and both agree on the words, your confidence rises. That is dual pipeline verification. If one microphone picks up a different word, you do not declare your friend incoherent. You check the noise, the placement, the window, the bias. That is episode 9, a philosophy of careful listening. Now, if episode 9 were only about measurement, it would be a technical manual. But episode 9 is deeper than that. It is about honesty. It is about the ethics of claiming knowledge in a universe where you never see the whole truth directly. When you begin to treat reality as language, there is a temptation to read too much meaning into faint signals. Episode 9 prevents that. It says, we have a hierarchy of confidence. We have windows. We have uncertainty bounds. We have consistency checks. We have cross-verification. We have canonical forms. We have falsification gates. The language is not a stage for imagination alone. It is a contract with evidence. This is why episode 9 can be summarized in one sentence. Episode 9 is the constitution of the Holophase program. Just as a nation needs a constitution that defines what counts as law, what counts as evidence, what counts as valid procedure, Holophase needs operational rules that define what counts as a reconstructed sentence, what counts as identity, what counts as equivalence, and what counts as disproof. The Constitution has several articles, and I will speak them in everyday words. Article 1. Define your observational window. Where and when are you looking? How clear is your view? What is the noise? What is the resolution? What is the coherence? Without this, your claims float. Article 2. Declare your reconstruction method. Are you inferring omega from time traces or spectra? K from fringes or gradients? V from envelope travel or feature tracking? Are you using phase retrieval, holography, interferometry, or another pipeline? Declare it so others can repeat it. Article 3. Check grammar consistency. Do mixed derivatives agree? Does the reconstructed dphi unify time and space slices? Does derived motion cohere with observed motion? Do topological invariants remain invariant unless a real event occurs? Article 4. Reduce to canonical form. If your sentence is to be compared, it must be expressed in a shared standard. This is where HLS becomes a living tool, not just a text. Article 5. Test equivalence operationally. Different-looking sentences are the same only if experiments cannot tell them apart within licensed windows. Article 6. Publish falsification conditions. Name what would prove you wrong. Name which measurement would break your sentence. Invite correction. Now you can feel the full essence. Episode 9 takes the Holophase language and turns it into a public, shareable, testable practice. There is another deep layer. Episode 9 is the moment we treat infinity responsibly. In episode 8, the jet J infinity fa is the infinite dictionary. In episode 9, we accept we never measure infinity. We always work with truncations, finite derivative order, finite resolution. Episode 9 therefore teaches the idea of effective slices of the language. A phenomenon might require only first and second derivatives to predict its behavior within error. Another phenomenon might require higher derivatives. Episode 9 teaches how to decide this by evidence. You add one layer and see whether prediction improves beyond uncertainty. If it does not, you stop. You do not climb higher just because you can. This is like describing a road. If you are driving on a highway, a map with only major roads is enough. If you are delivering to a specific house, you need street detail. If you are repairing the pavement, you need a microscope. Episode 9 says, do not demand the whole tree when a small branch suffices, but also do not pretend a small branch explains everything. Now, because you asked for a complete picture of episode 9, let me show its emotional arc as a story. not only a logic chain. At the start of episode 9, you are a new reader holding a sacred alphabet. You feel awe. But you also feel danger. You might become intoxicated by the beauty of the language and forget that reality is not obligated to match your dreams. Then episode 9 introduces humility. You cannot see phi directly, you infer. Then it introduces courage. Inference can still be rigorous if you build procedures and checks. Then it introduces community. Canonical form exists so different minds can compare what they see. Then it introduces vulnerability. The program must allow itself to fail if the data refuses it. And at the end of episode 9, the listener feels something rare. Not blind belief and not cynical dismissal, but disciplined wonder. Wonder tethered to method. So if I had to give you episode 9 in one metaphor, it would be this. Episode 8, build the language like a perfect compass in a clean workshop. Episode 9 takes the compass into a storm and teaches you how to navigate anyway. Because in the storm, the needle wobbles, the map gets wet, the stars hide. But you can still travel if you know how to correct for error, how to take repeated readings, how to triangulate, how to check consistency, and how to admit uncertainty. That is episode 9. And here is the final gift episode 9 gives the listener. The ability to say, I do not just see a phenomenon. I can name the holophase letters that define it. I can measure their fingerprints. I can test their grammar. I can standardize the sentence. And I can compare it across observers. That is what it means to turn a philosophy into a science. Now, as we close part 2, I will leave you with one simple practice that contains episode 9 inside it. Pick any phenomenon you encounter today. A bouncing ball, a flickering screen, a car passing by, a voice speaking, a ripple in water, a heartbeat. Step 1. Ask, what is the temporal signature? What is omega doing? Is it steady, modulated, accelerating, jerking? Step 2. Ask, what is the spatial signature? What is K doing? Is the pattern fine or broad, curved or straight, converging or spreading? Step 3. Ask, what is the motion signature? What is V doing? How does the pattern travel, drift, or stay locked? Step 4. Ask, what might be topologically stable here? Is there a countable knot, a persistent defect, a discrete label? Step 5. Ask, what can I truly know in my window? What is clear and what is guess? Step 6. Ask, what measurement will check my interpretation? What would disprove it? If you can do that, you already carry the complete essence of episode 9 in your mind. In the next part, we will zoom into episode 9's roadmap in detail, and we will build this operational constitution step by step. So the holophase language becomes not only a breathtaking vision, but a reproducible way of reading the universe. Remember the language we're learning. There is one field, phi, and every law of nature is a pattern in its derivative tree. Episode 9 is where we learn to read those patterns with real instruments, real limits, and real honesty, and still hear the universe speak.